friends. We are so excited to have you join us as we announce and demo TimescaleDB's 2.6 release. The big news is that with this release, you will have the ability to compress your continuous aggregates. Yes, folks, I said it. Compress your continuous aggregates. We are so excited to give you this functionality, especially since so many of you have been asking for it for such a long time. And the continuous aggregate fun does not stop there. Starting in this release, you will also have the ability to use our experimental TimeBucketNG function within your continuous aggregates. This essentially means that, at least experimentally, you will have access to time zone supported bucketing and the ability to bucket by month and year. Now, since compression is really the star of the show in this release, for the demo, I want to focus on showing you how to set up compression on your continuous aggregates. Many of you love and use continuous aggregates because they speed up your aggregate queries, but also because it allows you to save storage by downsampling your data, right? We can use retention policies to drop data on the underlying hypertable without affecting the aggregated data in our continuous aggregate. Very useful stuff. And now with compression, you can step up your storage saving game by also compressing your continuous aggregate itself. Super exciting stuff. It is good to note, though, that you cannot update or refresh compressed chunks. So when you do set up your compression policy on your continuous aggregate, you want to make sure to set it up on data that you won't be updating. We're going to talk more about that in the demo itself. And since we have so much to cover, let's hop right on into the demo and get this party started. So we're going to start off by attaching my Docker container instance. My database is within a Docker container, so first got to connect to that. So that's what this first command is. And then next, I'm going to select all for my stocks intraday table, just to give you a quick look at what we're really working with in this demo. And so this is stock data. We have time, symbol, price open, price high, price low, price close, and trading volume. So those are the columns that we're working with. And as you can see, we also are incrementing by 1 minute. So this data is incrementing by 1 minute. Just, good things to note as we move forward. So in order to show compression on continuous aggregates, right, we need a continuous aggregate. And in this case, I don't have any continuous aggregates on my table at the moment. So what I want to do is first create a continuous aggregate. So you can see here that I'm calling my continuous aggregate stock intraday daily. And my interval for this continuous aggregate is going to be bucketing by day. So I'm going from that minute incrementing data to now day data. So bucketing that up. And as you can see, right, I have average, price, high, open, close, low, all that good stuff. And then I'm also grouping it by symbol. And of course, since we have a continuous aggregate, we also want to have a continuous aggregate policy, which, is the refresh policy. This is what's going to refresh and update our data. And for this continuous aggregate policy, I'm going to set it up to update data from 4 days, to now. The end offset is going to be 1 hour. And then the scheduled interval is going to be 1 minute. And I'm choosing such a small schedule interval because I actually want to show you later on in the demo how compression, is not going to affect your refresh policies as long as you set them up correctly. So I will be adding data later on. So that's why I have such a kind of silly interval, especially, so my offset is 1 hour. But anyways, we will see why. So now that I have my continuous aggregate and I have a refresh policy on it, right, now I want to actually enable compression. So in order to enable compression on an existing continuous aggregate, I'm going to use the alter materialized view. state the continuous aggregate's name, and then set this timescale db.compress equal to true. So this is kind of the new parameter that we have access to with compression. In this case, I assume that many of you are probably going to want to enable compression on continuous aggregates that already exist. But if you want to make your life easier in the future and you want to enable compression when you create your continuous aggregate, you can do so by actually just setting it in the parentheses here after the with keyword in your continuous aggregate statement. So you just add a comma, then do the compression equal true. And then that will enable compression on the creation of your continuous aggregate. So either way, whatever works for you, whatever is easiest. Definitely in the future, I find it easier to just put in those parentheses. And now that we have compression enabled, right, we can actually set up our compression policy and see the compression in action. So here, right, I'm doing select add compression policy. So that's how I add the compression policy. It's the same command for a hypertable compression. And then I just state the name of the continuous aggregate and then an interval of 7 days. Now, if you note here, right, I picked an interval of 7 days. So this means that I want to compress data that exists before that 7-day mark in time. So all the data that exists in my continuous aggregate from 7 days to, before that time period, that's what I want to compress. And if you look back at the refresh policy, we see that we are refreshing and updating data from 4 days ago to now. And the compression policy is 7 days to all the time before. So we have to offset our compression policy and the refresh or the continuous aggregate policy statement. So that's how you avoid having compressed chunks that you need to refresh, right? If we offset the compression policy from our refresh policy, then we should never run into the case where we need to automatically refresh data that is compressed, right? And so that's what I was talking about in the beginning of the video when I mentioned that you can't update compressed chunks. And so to avoid that, right, you just need to offset the two policies just to make sure that they don't occur on the same time periods. So, right, we have compression set up, but what about if we want to see how it's actually acting? How well is it compressing our data? Well, we can do that, and it's very similar to how you would check compression stats on your hypertables. But in this case, we actually need to find out the underlying name of our continuous aggregate hypertable. And so to do that, I'm going to call this timescale DB information compression setting. So this call essentially gives us information about our compressed hypertables. And so in this case, for our continuous aggregate kind of underlying materialized hypertable, it's called materialized hypertable 22. So that materialized hypertable 22 is the name of our underlying kind of hypertable for our continuous aggregate. So once we get kind of the underlying name for our continuous aggregate, then we can actually use this hypertable compression stats command and specify the timescale DB internal materialized hypertable 22. Note that your hypertable value, that 22, is probably going to be different. So just when you run through it, you want to make sure that you get the right underlying hypertable name. And in our case, with this table, we see that we have a total of 7 chunks in our continuous aggregate, 6 of which are compressed. And we see that the before compression total bytes is around 9.5 million or so, while the after compression total bytes is around 3.5 million. So we're seeing about 61% compression, which is very cool. And just to show you that when they are compressed, they act the same as when they're not compressed, right? Or very similarly. I want to add some new data to our underlying hypertable and kind of see how it refreshes in the continuous aggregate. So then if I use the select count all statement from our continuous aggregate, I see that I have a total of around 30,000 records, right? 30,097 to be exact. Then I'm going to add a bunch of new data to the underlying hypertable. So that's stocks intraday table. And we see that we added around 143,000 records to our underlying hypertable of our continuous aggregate. So with our refresh policy, we then should see, if we were to select the count from our continuous aggregate, we should see that number go up, right? And so when we do run the select count from our continuous aggregate, we do in fact see that the number increases, right? That's as expected. If we have new data added to our underlying hypertable, we should see new aggregated data added to our continuous aggregate. So we see that, and that is working well. But another important feature of continuous aggregates is the ability to save storage by deleting or removing data from the underlying hypertable without affecting the aggregate itself. We often use retention policies to save on storage, and that's really the purpose of compression as well. And so to show you that retention policies should also work exactly the same for compressed and uncompressed continuous aggregates, we're going to select the count from the underlying hypertable, the stocks intraday, and right, we have the number for the rows in our continuous aggregate as well. So we see the records for our continuous aggregate and the records for our underlying hypertable. Okay, now when I add a retention policy, we should expect that the continuous aggregate number should not change while the underlying hypertable does change. And this is a retention policy for 1 month on the stocks intraday hypertable. So that's the underlying hypertable, right? So let's just re-query our select count. We see that the continuous aggregate, we have that 30,300 number. The aggregated data is not changing after our retention policy. But if we look at the select count from our underlying hypertable, we see now 1 million after the retention policy from 13 million that we had before. So, right, the retention policy worked. We have fewer data points in our underlying hypertable, but the continuous aggregate was completely unaffected. So that is exactly the type of behavior that we would expect from a continuous aggregate. And in this case, a compressed continuous aggregate. So it's cool that really no functionality should be changing in your continuous aggregate workflow as long as you set up your compression policy to be offset from kind of what you're refreshing and updating. So that's, the important part of all this. And yeah, definitely check it out. Thank you all so much for joining us, for using TimescaleDB, and for being an amazing community. We really hope that this new functionality available in TimescaleDB 2.6 is as exciting for you all to jump in and use as it was for us to develop and release. Make sure to try out compression on your continuous aggregates, and we would also love it if you tried out our experimental TimeBucketNG function as well. With experimental functions, we are always looking for your feedback and your help testing the feature. So if you do try it out and you find any issues, make sure to let us know on GitHub. It helps us move it right from experimental to fully supported. So we need your help. Overall, thank you so much again for your time today, and we hope that you have a great rest of your day. And as always, happy coding.